Hi, everyone. Thanks for joining us today. We are talking about IoT security and the role MQTT can play in securing your IoT estate. My name is Gaurav Suman. I'm based out of Ottawa, Canada, and I lead product marketing here at Hive MQ. Let's begin with why IoT security is top of mind for developers and architects. IoT Analytics published a report recently. What it tells you is that approximately 27 billion devices will be connected by the end of 2025. This trending reflects the bit of a slowdown we've had in IoT adoption because of the current chip shortage we are facing worldwide and the amount of time that it might take for the recovery. Irrespective, 27 billion connected devices by the end of 2025 is a huge number. Now, couple that with the kind of news that we've heard about IoT devices, right? Somebody's pacemaker has been hacked. The many utility companies in the US uh, were attacked late last year. There are experiments where somebody will show how a connected car can be driven off the road. Now, these are news from the past several years, and as I mentioned before, the penetration of IoT is only increasing. So, why is it that it's hard to implement good security on your IoT setup? So, let me walk you through what those reasons potentially are. IoT is unique, right? Your devices have limited power and they're mostly running on batteries. And these devices are mostly way out in the field. These are not sitting behind, a multi-tier physical security system, which is difficult to break into for bad actors. Here we are talking about a connected bike or a IoT sensor in a remote area, which can be literally physically broken into, and somebody can try to reverse engineer it, figure out potentially harmful information about all of your IoT deployment. And how about the fact that many of these connected devices have a very long life cycle? So imagine an OEM manufacturing cars, a connected car, right? I mean, these things will be out there for 10, 15 years. How do you keep it secure for that long a time? Right? And it's not always possible to do a firmware or software update on these endpoints. Now, before we go deeper into this conversation, I want to show you who we are and why it's a good idea to hear our point of view on IoT security. We are HiveMQ, and we serve nearly 150 customers across continents and use cases. And security is one of the key pillars of our platform. We secure IoT data end to end. And as you can see here on the right, we offer a full toolkit to make sure you are able to implement your security profile and posture with full confidence. There are many out of the box security features we have, and then there is the enterprise security extension, which gives you full control over your security architecture. We'll look at some of those aspects as we go on along here. Security, as most of you probably know, is not a feature, right? It's a strategy, it's a mindset, it's something that needs to reflect on multiple layers of your organization. It's the policies and practices that you create and adopt, and it's the security you maintain on the network itself. It's the hosts that you choose to use, bare metal, virtualized, SaaS, cloud, whatever it might be, and of course how applications and data itself is protected. Now, in this context, I quite like the this quote from the 34th President of the United States, Dwight E. Eisenhower, where he says, "We will bankrupt ourselves in the vain search for absolute security." This was, of course, said in a particular context, but I like this because, as you can tell, I mean, this is work, but there's really no choice. Let's zoom into application security here. This is where our MQTT applications live. So, that being the topic of the day, let's take a look at the stack of security needs of IoT connectivity at the network layer, at the transport layer, and at the application layer. At the network layer, you have the threat of unauthorized access, denial of service, man in the middle attack, etc. And one possible remedy is to implement an end to end VPN and secure the full connection. Sure. Now let's move up, transport layer. Now, here the risks are more around eavesdropping and replay of data and man in the middle attack again. And this is because, despite security on the network, the application level connections are still vulnerable for attacks. Now let's go one level up on the application level. Your services here could suffer from a denial of service attack. There are repeated unauthorized access requests and comprehensive authorization authentication mechanisms. That is what can potentially help you manage those challenges. But what is so special about MQTT? Now, MQTT is made for IoT. It's the de facto messaging protocol for IoT. It's built for extreme scale. We're talking, millions of devices, billions of data points in many cases. It's a pub sub architecture. And what's interesting here is it is meant to be easy on the device and pushes all the complexity to the server. And we'll talk about what that server looks like and what it's called in the IoT context. And it's built for machines with constrained resources, battery, processing power, etc. And one of the more important things here, it's built for reliable communication over unreliable channels, right? In fact, this is what makes it useful and usable in a variety of use cases: connected cars, industrial automation, logistics, fleet management, telecoms, and generic IoT messaging middleware use cases. What I quite like about the specification of MQTT is the choice of words here. So, what are they saying? They are saying MQTT is deployed in hostile communication environments. This is not standard LAN WAN. This is a hostile communication environment. And in those implementations, you will often need to provide mechanisms for authentication, authorization, integrity of data, and privacy. This means the specification has many facets, some of which cover authentication through, client ID, username, password, etc. And it's recommending controls for access to data. Now, remember, this is just the specification of what's called MQTT, right? This is not a solution. It's just laying out what you should look to achieve. And when you understand the specification, you realize that the MQTT server, as it was mentioned before, or the broker, you can alternate between those terminologies. The broker is at the center of all the action. And the beauty of this MQTT architecture is that the heavy lifting is happening on the server side or the broker side. And the clients, because of that, can be lightweight. Right? On a high level here, the broker is doing three things. It is decoupling the open and public untrusted environment from the secure backend of an enterprise. It helps you conserve bandwidth and resources. How does it help conserve bandwidth? Well, there is, as I mentioned, the heavy lifting is happening on the brokers side. So the data and the amount of data coming from the clients is optimized thanks to that. And there are interesting other features like X509 certificates, digital certificates. They can be used for even application level security. What it also helps you do is helps you centralize the policy. So you can have subscription and publisher control on your topics, and you can get denial of service protection. Essentially, it keeps traffic in its lanes. So I mentioned a few things here, right? I mentioned X509, right? Or transport layer encryption using X509. I mentioned denial of service. And many of you might know what these are, but before we look into the deeper controls of IoT security, it's perhaps important to refresh your memory on a couple of foundational concepts. So MQTT is a TCP-based protocol, and the TCP connection can be secured using TLS. So the applications are listening in on port 1883 for MQTT, and if it is secured using TLS, then they are listening in on port 8883. So TLS is what helps secure the communication and authentication between server and client, and it uses certificates to help the client authenticate the identity of the server. So with your permission, I'll just tell you something interesting about the number 1883. 1883 was the year in which the first picture of a UFO was ever taken. So on the right, you see a screenshot I took from Wikipedia, and an astronomer by the name Bonilla has taken this picture in August of 1883, where Bonilla has spotted and taken a picture in 1883. Again, I'm reminding you of unidentified flying objects. It was later debunked to be something else, but you know, this is one of the earliest, rather, the earliest picture of a UFO being spotted. All right, so let's talk about how MQTT helps secure IoT. So picture boarding an airplane. You know, you're getting to the airport to get onto an airplane. Let's say it's an international flight, right? Now, if you're getting on an international flight, you can afford to forget many things, but there's two things you absolutely should not forget. One, your passport, and second, your boarding pass. It's the passport which helps authenticate who you are. You're saying you're person this, the passport confirms that this is who you are, and then it's the boarding pass that confirms that you are allowed to access the resource. What's the resource here? In this case, it's the plane ticket, or rather the seat on the airplane to the destination that you chose. So only authentication is not enough, and neither is only authorization. You have to have both, and they both work hand in hand. With that in mind, I want to walk you through some more details from an enterprise context. Let's begin with authentication. There are many ways to authenticate, and these can all be used in combination. Client ID, username, password, digital certificates, OAuth, JSON Web Tokens. Among other things, the choice absolutely depends on the capabilities of the client itself, right? So if it's, let's say, a modern connected car, you know, the capacity computing power on that endpoint is high. So you could use more sophisticated options like OAuth, and in other use cases, you might make different choices. Now, from an enterprise perspective, just relying on client ID and username password will never be enough, right? So let's look at two advanced options which are now commonly used. One is to use digital certificates, X509, for example, in your TLS authentication. And the second is to wire your MQTT broker and auth store like a database or an enterprise LDAP system. And we'll look at an example of that in pretty soon here. Now, each of these, using certificates or taking the other option of wiring your broker and the auth store, they both have their own advantages and disadvantages. Let's look at them a little closely. So in case of authenticating in TLS using digital certificates, you would typically rely on a public certificate authority like a VeriSign to give you digital certificates for transactions between client and the broker. And that's absolutely recommended if you're using an open and internet facing infrastructure. But with IoT, you also have the option to use a private certificate issuing mechanism. Now, that's an interesting use case for, say, shop floor or other, closed loop application. And there's benefits and drawbacks to it. The benefit is that you don't pay a third party, and the risk is that because this third party itself can carry a risk of intrusion or breach, right? But if you choose to not rely on a public authority, then you have to build this certificate management infrastructure in house, and this is that might mean significant manpower and resource overhead, right? But if you choose to take the path of using X509, there's a couple of things I would love to walk you through what you need to consider in this case. X509 is a great option when you know who is at the other end. As in, let's say you are the manufacturer of this endpoint, the example of a car I gave you before. So you know who's at the other end, as in you're sharing a set of security practices. You're expecting the client to send you a valid and a usable certificate. You're coding the endpoint in this case, and the endpoint knows that it's going to follow a certain process around fetching and sharing a digital certificate. But if the client is, say, a community created project, and you're hosting a public facing broker, a digital certificate based approach might not be possible, right? Also, managing the life cycle of the certificate itself is hard. As I mentioned before, you need to be able to control all your clients, and in case a certificate is leaked, right, it's compromised, you need to give your server the ability to identify invalid certificates. This can happen in one of two ways. One, CRLs, certification revocation lists, and these are really coded on the broker, and it's hard to scale them. Every time you find out a certificate has leaked, you code that into the broker, and then that has to replicate across your cluster. And in a real life scenario, it's it's a lot of work and it's time consuming because the the broker has to parse through the code every single time there's a connection request to know if they should allow the connection or not. The other option is what's called OCSP, Online Certificate Status Protocol. So in this case, the server here, as you can see, is checking with a local cloud-hosted OCSP provider or an HTTP responder to make sure certificates are still valid. So picture this: every time a client wants to connect to a broker, we need to check in with an OCSP responder. Now, this can't be good, right? It's expensive when you count the number of calls that you need to make to fetch a good, no good kind of a response. And it can slow down the system if there are frequent disconnections or a high number of clients. And also think of scenarios where the OCSC responder itself is offline or is overwhelmed. Should your systems continue without authentication? Or do you think they should declare an attack on the infrastructure and trigger what might likely be a false alarm? So, so picture this: there are a million vehicles on a connected car platform, and an availability zone that's serving them goes down briefly. Right? There's just a snap; it goes down, comes back, perhaps in minutes. And let's assume it's a well-designed distributed architecture, so generally everything connects back well. But now these million or so cars have to re-authenticate with the platform. So can you see the problem here? Right? The bottleneck in this case becomes the OCSP responder. How can they now authenticate these millions of endpoints and bring them back into the system? Now, there are solutions to that, and HiveMQ brokers support this mechanism, which is called OCSP stapling. In essence, what's happening here is that the broker is going to cache the certificate from the OCSP responder and keep refreshing them at regular intervals. This further decouples the client from the backend systems and helps keep the business running smoothly. Now I'm going to pause here, right? Think about this for a moment. We are talking about security, but this one really is a scalability issue, right? You are not able to authenticate at scale. You might be able to connect at scale, but you're not able to authenticate at scale. So that's what you're solving here. Right? So when you think about scale, I encourage you to think about the full workflow and all the vulnerabilities at the multiple levels, and that also includes authentication. Right? Okay, I hope that made sense. And I know we are spending quite a bit of time looking at authentication because it's the key, and that's what lets the clients in. And interestingly, what HiveMQ allows you to do is use the X509 authentication to also authenticate the parties for the application layer itself. Essentially, the broker is reading and using all relevant fields in the certificate to save cycles in authentication on the application level. So that's one of the efficiencies I mentioned to you before. Let's now talk about the second advanced authentication option, which is to wire the MQTT broker and the auth store. So the auth store or external authentication system, it could be an SQL database, it could be a WebSocket based system, it could be an enterprise LDAP, it could be an access control list. So when would you use this? You would use this typically when the client is not in your complete control, or you want to have the flexibility in your deployment without compromising security, right? So remember, we are always constantly trying to balance functionality and security here. And sorry, I went a slide ahead, but yeah, this is some of the systems that I mentioned to you. And I can't stress this enough. Not all brokers can support this kind of a pluggability on authentication and authorization. So with that in mind, let me just walk you through a quick code snippet. So what's happening in case of this custom authentication logic is that the broker is calling the extension at runtime, and that extension has got what's called callback interfaces. And these interfaces help you plug into events inside the broker, right? And that helps open a whole world of possibilities with customized authentication mechanisms. So in this example, we have a callback from a callback registry. Now here, the client credentials data parameter, this is what contains, all the data that HiveMQ is gathering from the connecting client, the username, password, certificate, etc. And where it gets interesting is that even if this authentication returns a false value, the broker has the option to check other extensions and request authentication, right? Now, remember, you can push this logic further, right? When we talk about authorization, we are concluding that this particular client did not pass a default authentication, but a different channel, rather, a different kind of a challenge. You can choose, how do we treat this guy now, right? What can they be allowed to do? So you authenticated them on a certain level, they failed, then you authenticated them on a certain other level. Now you're saying, yeah, sure, this guy didn't authenticate uh, on level A, but on level B. Based on that, we're going to grant them permissions, as in authorizations, to do X, Y, and Z, right? So you have that choice and define workflows only because you have this flexibility on the authentication level. So just based on your business use case, this extensions ecosystem can be super powerful. All right, let's look at authorization now. That's the boarding pass, right? That's what's going to get you to your seat and to your destination. So the quick reminder, or perhaps a primer rather, for people not so familiar with MQTT. The only way to get data in and out of a broker is via topics. And a client can publish to a topic, or it can subscribe to topics. As a default, they can publish and subscribe to all topics, and that's obviously not what you want. You want to keep topics allocated by various categories, various workflows. But no, you don't want all consumers and all subscribers to be accessing data across all topics. So that's where authorization comes in. So as a client, it can be allowed and authorized to publish to a topic, and they can subscribe to topics. And as a default, they can publish and subscribe, as I mentioned, to everything. So what we can specify on the client is where they can publish. Which QoS level can they publish on, or I should say, what QoS level can they publish with, and what kind of operations can they perform? Are they only reading? Are they writing, etc.? So this is something which is important to just make sure you are governing the authorization properly. By the way, going back to the idea of ease and simplicity, and balancing that with security, it's still easy for the client to figure out what they are allowed to do. So a client, when it connects to the MQTT broker, um, they can request and query to get information on what they are permitted to do. It's not, I mean, this is where we are balancing the ability for them to function properly. It's not a security wet blanket that we're placing on everything. They are allowed to connect, they're allowed to inquire, and then they can choose to inquire, okay, how am I supposed to, what am I supposed to send, right? Now imagine you have somebody connecting, or a client connecting, and now they're sending data in a way that they were not authorized to do. Okay, tricky situation, right? They connected, they authenticated, and now they're sending data, but they're sending data in a way that they were not authorized to do. So what would you want to do? You could take the what comes to mind as a default approach, which is to kill that connection, tell them you're being naughty, you're being whatever, right? Unproductive, so let's get you out of here. Or you could accept that data and not worry about it. Do not forward it along to the subscriber they were trying to perhaps reach to. Is that a good strategy? I mean, you decide. It's up to the business logic. Are you willing to spend cycles letting the client know that you were trying to connect to us? Yes, we were good. Now you're trying to send data which you are not authorized to. You can choose to not say anything back to them about it. Now, this can be part of your security posture, how you're trying to govern your whole infrastructure. But by not sending an acknowledgement, back to whoever it was sending you the data, you are choosing a certain strategy here. So again, these are flexibility and elements available to you based on your business use case. From an admin perspective, you can use access control lists and role-based access control to access your data. As an example, HiveMQ enterprise security extension gives you the ability to use permissions, which can be stored in external data sources like an SQL database, and we talked about it before. And you can add, remove users, or change the access rights for these users quite easily and quickly. Okay, with that, we come to encryption. Let's talk about encryption briefly. Now, as a best practice, you always want to use the latest version of TLS and the latest cipher suites for sure. And using certificates from trusted certificate authorities. Now, it's it's important that you understand the difference between using TLS and encrypting the payload itself. If you encrypt the transport layer with TLS, you are encrypting everything, the header and the payload. But if you're choosing to encrypt just the payload, the header information is exposed. So the metadata can be used by a bad actor to figure out what your topic structures are and some other related information. Now, that may not be the worst thing, right? And bear with me as I explain this to you. Yes, you would absolutely want to have the latest version of TLS securing your transport layer. But what happens is, and I'm stressing this, that because it's an IoT use case, it's not always feasible for the endpoint to have enough uh, compute power or bandwidth to support TLS encryption. And if it's a closed network, and we have a client who's using us to provide services again inside a closed loop inside their network to configure and manage some remote infrastructure, and in their case, these are portable traffic signals. And what they're doing is, before using us, they were with one of the large hyperscale service providers, and they had a condition that you have to have TLS from your endpoint going into their cloud. Now, by going into their own private cloud now and using us as a software broker inside their network, they've been able to turn off TLS. They still encrypt their payload, but they've been able to turn off TLS and saving immense amount of bandwidth and able to conserve batteries. Now they are managing, or I should say, installing traffic signals and pedestrian crossings at remote infrastructure at remote locations. So they need to conserve the battery. They need to consider the safety of the people on site. So it's important for them to make sure their devices can last a long time when they're out in the field. So that's a bit of a trade-off. But then again, the flexibility is with you. You can choose to turn off TLS, encrypt the payload, and still meet your security goals and objectives. One other thing which is perhaps worth mentioning, we talked about denial of service and overload protection. So security is just not about encryption, authorization, authentication. Here we are talking about somebody trying to actually overwhelm your system. And the controls available to you here are very many. As you can see here, you can choose to throttle specific bandwidth. You can limit connections. You could also activate what's called the cluster overload protection option. And what it does is any overactive publishers are stopped, and you can then monitor them to see why is it that they were trying to do such malicious activity. Also, these are things you learn as best practices, and over time our company has supported many businesses, and we know that just this, what might seem like a simple and easier act of limiting client ID and topic length, even that helps make sure that the computing power on the system is intelligently used and does not overwhelm the system. So the simple act of limiting client ID and topic length itself, that helps prevent malfunctioning of IoT access. So if you bring it all together, it helps you perhaps make a smarter choice about choosing a secure MQTT broker. There's obviously many options out there, some open source, some from large hyper cloud companies. HiveMQ is an enterprise ready product. We are performant, we scale massively. We comply to the full MQTT specification, MQTT 3 and 5. Our broker is very deeply observable, and there's deep tracing available on many levels. As I mentioned to you, there's pluggable authentication and authorization available, so you can access other systems and decouple security expertise and your broker infrastructure. There's overload protection, support for TLS, and then professional support available to you. And I'm talking 24/7 support, plus also professional services to help you make a secure and a productive deployment for your IoT infrastructure. The HiveMQ security architecture is a portion of that is what I walked you through in my presentation so far. But just to recap, there is built-in capabilities, and then there is also some extensible capabilities which come with the HiveMQ Enterprise Security Extension. And this is where there's several other additional features you can activate. And one that I particularly like is the ability for us to now help you chain authentication mechanisms. And we talked about those examples. If authentication one fails, you go to two. If that happens, then what kind of controls you give and access you give to that client versus others. Those are smarts that you can play out with us, thanks to our deep security expertise and the enterprise security extension that comes as an addition on our platform. So just a quick view, a closer look on the enterprise security extension. I covered a bunch of things around this already, but just goes on to show that we have very narrow and particular focus on HiveMQ rather I should say security of IoT and MQTT. So before we close here, quickly wanted to reference, or I should say recommend, a few resources available on our website, and they are all available at no cost to you guys. There's a Get Started with MQTT guide. MQTT is growing in popularity, but then still it's important that you understand exactly where it applies, where it's good, where it may not be the right fit. It's not the solution to everything in the world. And that's why it's important that you understand what MQTT can do. And there's a ebook and training available on our website. There's an evaluation edition available. There's also our HiveMQ Cloud available for trial. You could visit our blog series and learn more about security fundamentals of HiveMQ. And I should say security in MQTT in general, but then also what HiveMQ can do and will do to help you out. Remember, MQTT security, MQTT specification is something that we fully support, and then we do more. So what you learn in terms of security fundamentals of MQTT will apply generally, and then you'll also get a chance to understand how a HiveMQ can particularly help you bring in those features. One other webinar which we have done, I believe late last year, and the people you see on the picture here are Maggie, who's our product manager, and also Georg Held, who's heading our product development team. They did an excellent webinar on 5 pillars of IT security for MQTT. So please do make time to watch this, and I'm sure you'll feel so much better enabled. I did my best explaining to you some of the high-level elements of authentication, authorization, encryption, denial of service. I explained to you the whole stack you need to be able to think through. And then if you want to get the broader approach, the classical approach on the 5 pillars of IT security for MQTT, Georg and Maggie have done an excellent job in this presentation. So with that said, I'm going to close and hand it back to our hosts today. Thank you so much for your time. I greatly appreciate it. My name again is Gaurav Suman, and you're welcome to connect with me on LinkedIn if you like. Look for Gaurav Suman. I'm based out of Ottawa, Canada, and I work for HiveMQ. Thank you so much for your time.